The question here says find the exact value of the indicated trigonometric function of theta. Now we're told that tan theta equals -10 all over 7, and then we're also told that theta lies in the second quadrant. Now find the cosine of theta based on these two informations. Now note, it says find the exact value, so do not use a calculator for this question. So let's draw this. So what we have is this. Let's say this is what we have, something like this. This is our x and this is our y-axis. This is the x-axis, while this is your y-axis. Now we've been told that theta lies in the second quadrant. Now this is your second quadrant here. So theta lies in this quadrant, so that implies that the angle is going to follow this orientation, and then this is going to be your reference angle, which you're going to call theta. Now we are told that the tangent of theta equals -10 all over 7. So if I'm going to join this triangle, so the tangent of theta equals opposite all over the adjacent. So the opposites, so we have the tangent of theta equals -10 all over 7. So this is the opposite here. Now since this is the opposite and the opposite lies above the x-axis, it implies that the opposite must be positive, right? So this has to be 10. So don't get confused by thinking because you have a negative sign here, what you have here must be -10. No. For the mere fact that you have a negative sign here implies that the negative sign could be for 10 or it could be for 7. So just note. Now, and what made my justification is because the graph I'm seeing here lies above the x-axis. So and then since this is the opposite, then the y must be positive. So it says the tangent equals the opposite all over the adjacent. So my adjacent, which is this side here, must now be -7, which is feasible because this is the other side of the origin, so it has to be -7. So anyway, our aim is to find the cosine of theta. So to find the cosine of theta, which is the adjacent all over the hypotenuse, so I need to know this side here. So I'm going to call this side, I'm going to call it r. Now how do I obtain r? Because this is a right triangle, I can apply the Pythagorean theorem, and that says that the square of the hypotenuse equals the sum of the squares of the other two sides of the right triangle plus -7 all squared. So 100 squared is going to give you 100, -7 squared will give you 49, and this will give you 149. So r squared is 149, then r is just going to be the square root of 149. So my r is the square root of 149. So based on this information, I can find the cosine of theta. The cosine of theta is the adjacent, which is -7, all over the hypotenuse, which is the root of 149. So this is your final answer. Now, because you might want to remove the root sign here to rationalize the denominator, so you multiply both the numerator and the denominator by the irrational number, that is by root of 149 divided by the root of 149. So what you have here is going to be -7, the root of 149 divided by the roots times roots. It removes the square roots, so what you have is 149. So this is going to be your cosine of theta. So both answers are correct.